Alright guys, this is your host Amarbir from Chandigarh Data Recovery. Welcome to another episode and a new case. Although I do several cases in a day, I don't get so much of time to create videos for you, but now I'm more regular with creating videos. This is a Western Digital 1 terabyte hard drive from one of my customers from Ludhiana, Pranav Sehgal, and this is the Western Digital My Elements hard drive. So I have already removed the hard drive from the plastic casing. So this is the hard drive that I am talking about. Now this is the older series of Western Digital WD10JMVM-11AGJ-AJG-S2. So this is like this is the FB Lite series hard drive, and this is a 2 platter and a 4 head hard drive. I would rate these hard drives to be very reliable. They were very nice. Obviously, we had a lot of cases coming from them because they were sold in millions and millions, and a lot of people don't really care about how they treat their hard drives, which is one major cause of the hard drives getting bad. Anyhow, so this is the older series. The newer one is the Palmer series, and the Palmer series basically is a single platter 2 head hard drive. It's a SMR shingled magnetic recording hard drive, and this is not a shingled magnetic recording hard drive. This is the older type of hard drive. So we have this case, and let's hook up this case to my computer and have a look how it is responding, what it is saying. I don't know what is the issue, but this case had come to me a few days ago and it was pending for approval. So I thought that might be I'll create a video for you along with this. And today I am not going to make that mistake that I made last time, that I was doing the screen recording and ultimately that was all haywire. So I'm not going to do that. I'm going to prepare my PC and then we are going to hook it up and try it out. Then we'll shoot another clip and simultaneously start the recording and do this. So just wait. So now let's hook it up and prepare the entire system for this. Okay, so the sound of the hard drive's spin up process was not as bad as I was thinking. It is not behaving too bad. So now let's see what my system has to say about this. Alright, so the hard drive is hooked up with the computer. Now let's see what my tool is telling me about this hard drive. Right now there is nothing fancy I have done. I have just connected this hard drive to a typical Windows PC. But I have definitely modified some parameters of my PC so that the hard drives are not mounted automatically. They don't mount automatically. So certain times if a hard drive is connected to a USB port, it does not mount immediately, so I don't get that system freezes that typical people do get. Now let's see what we have on a screen. It says caution, and if you see the power on hours, the power on hours are basically 1000 plus times it has been powered on, and more than 3000 hours it has on its count. That's 137 days and 9 hours of continuous usage. So this is a case of a typical hard drive which has become now degraded, and that is the reason that when the guy is connecting it to his computer is actually halting and preventing him from access his data. Now let's see how we bypass this issue and give the final result to the customer. Okay, so what I have done right now is I have removed the board from this hard drive, and this is the PCB that was connected on this board. So what we need to do is, if you guys see, this PCB has a native means that the USB interface is soldered onto the main board itself using a SATA to USB controller, which is right here, this chip that you see. So what is our first step? Our first step is that we need to convert this PCB into a SATA PCB, either by modifying this or by arranging a different SATA board which is compatible to this USB. And then we have to transplant the adaptive parameters which are stored inside this PCB into the donor PCB, so that SATA donor PCB becomes totally compatible to this, and we are able to access our hard drive's data and hard drive's firmware, both things. So now screen is right here, and I am going to hook this up. You will see it. I am going to make my video go down a bit here. So here you go. The product is attached to my system now. Now let's run the tool. Now we are reading the adaptive parameters from this case. We are done with that step. So now we have no other use of this particular board as of now. So we will safely keep it here. And the next step would be that I arrange a compatible SATA board that I have to fit in here. Now give me some time to do that. Okay, so I'm back. Here is the compatible SATA board for that particular USB PCB. Now I will interface it to my tool and give it some power. You guys might be seeing on this that right now the busy light is on because the power has been provided to the USB port, to the SATA PCB, but the SATA PCB is not able to find this entire hard drive. So it's just trying to find, and after some time this busy light will go off, and we will have access to the SATA PCB's internal firmware, which is stored the adaptive data ROM, which is inside this, and then we will program that ROM with the file with the data which we had leached out from this patient PCB. So wait a little. I know that this gets a little boring at certain stages, but my videos are live recoveries. I mean, I really doubt if some of my current video has been under 30 minutes, because you just can't make those videos for 15 minutes. Obviously, not many of you people they can watch longer videos, but trust me, when I am interacting with you people, you are like my family and friends. Some of you are younger than me, some of you are more seasoned technicians than me. So I do my bit part of communicating with you, communicating with my clients, and here we are. Now on the screen right now, you will see that the busy light has gone, and we are now able to access this board. So let's go into the utility. Let's do an auto detection, and FB light is selected by default. Let's initialize this. So it's initialized. So the first step is that we are going to program the ROM, and we are going to take the ROM which we had stored over here. So this is like 4178. So this is the 4178, and we'll say OK to that. I won't give any profile name. So it will erase the ROM, and then it will program the ROM. Now the board is prepared. If you guys see, the ROM version is 5000. Sorry, it's a 500501C. This was the ROM which was there inside this SATA board, and once we have programmed it, I don't know what is the code now, but here is the board, and let's put the board on this hard drive right now. So let's take it a bit down below. Here you go. So the board is fixed, and so the board is fixed onto the HDA, the head and disk assembly. And now let's fire up our tool and see what we have to see. So the busy light is again on. And the hard drive now is in ready mode. Let's run the tool. Here we go. Our capacity, serial number, firmware, everything is, model number is detected. We say auto detect, it will again go to FB light, then we click on to utility start. And if you guys have a look at the ROM version, this is 0016, then 0056. So the ROM version has changed because we have programmed the new ROM. We have adapted the SATA board to the same as this USB board. And now we have to first solve our problem. Then only we'll be able to clone this. You should never clone a hard drive which is in such a degraded mode by by just because you have the tool, you just start over cloning. This is not the right way to do it. So the first thing we do is that we will archive our firmware and see the response of reading the modules. Right now the response of the modules is not bad, it's very nice and it's going on smoothly. Now this firmware that I am archiving is being archived onto a profile folder. I also like to keep my firmware in my database. So after doing this, I'm going to do that again. So the ROM, the modules and the tracks are being read. Now let's start dumping the firmware into the database. So when you dump the firmware in the database, there is another check that the tool does. First it will read everything and then mark that which modules are being able to read and which modules are not being able to read, and then it saves it into the database and it has this details also stored inside that this is how it is done. So here you go, and right now it is not archiving the firmware, it is actually reading it, and now it is archiving it. Yeah, the screen goes black again and again and again because this is how this bloody OnePlus, my phone, records. It keeps on changing the focus, I think the autofocus, and suddenly it becomes black sometimes. I just move my head and it becomes black. Here you go. And now it becomes white again. So all the people who are a little blacker, and they want to become white, they can come in front of my phone, just turn their head like this, it is black, and then they turn their head like this and it's white. I am sure that some of my friends are going to say that this section what I just said is the best part in the video. But anyway, so this is how it is. So stuff is going on. Let's focus on our work. Now there is something I like to discuss with you. These hard drives can find out which sectors are bad and automatically reallocate them. So we have to stop that process, and we have to stop a number of other processes so that we can gain access to the hard drive properly when we are doing the cloning part. So here we go, and let's modify that. I never clear relu list. The reason is because the relu list has the reallocated list has a lot of reallocations inside it, and it makes no sense to clear it. I don't know, some of you are half mad that you keep clearing them. Why do you need to clear the relu list? You will only clear the relu list if the relu list has become corrupt and the firmware is not able to parse it properly. Otherwise, what is the idea of clearing the relu list? Stupid idea totally. So instead of we will disable collection of relu list, we will disable relocation, and we will disable the smart update, and then we will do this. So this is one step that we have done. Another thing that we need to check it whether this hard drive it's a self-encrypting hard drive or not. So currently this hard drive is not self-encrypting. So here we go. Let's see some sector of the hard drive, and if we focus on sector number 0, which is the master boot record, you can see that invalid partition table, error loading operating system, missing operating system is written over here, which means this hard drive is not self-encrypting. This particular piece is not self-encrypting. So now what we need to do is, our drive is now totally prepared to do cloning with. So now instead of wasting my PC3000 and DFL and MRT ports, I would like to put it on to DeepSpark and finish this job. So let's close this hard drive. We go back. We shut the hard drive off.